All right, I thought we'd give a good attempt at this AP Calculus optimization problem. It says a Norman window is constructed by adjoining a semicircle to the top of an ordinary rectangular window. Find the dimension of a Norman window of maximum area if the total perimeter is 16 feet. So the way I started to do that was this. I started to just set this up. This would be y. Sorry, this would be x. This would be y. And this distance here for this circle, just to give you an idea, would be x halves. So that's kind of where I'm starting from. So first I'm going to start my secondary equation, which I think is going to be the perimeter, and the perimeter is going to be 16, and that 16 is going to be equal to this, right? Just walking around this thing. So this is what I'm looking for right here, just to give you an idea of this perimeter. I'm looking for this here. Here's the perimeter of a Norman window right here. So if that's the perimeter, I would get that by getting x plus 2y, right? That gives me x plus this y and this y. Now I need the perimeter of half of this circle. The perimeter of a circle is 2 pi halves, but I only get half of it, so I get pi, and then I get r radius, which would be x over 2, right? And the reason that's true is because this distance from here to here is x halves. So there's the perimeter. One thing I probably would do, because of this 2 at the bottom, is I'd probably multiply the whole thing by 2, which would give me 32 is equal to 2x plus 4y plus pi x. And hopefully you can see the reason that I did all that is called grounding. It's because I wanted to get rid of this 2 in the denominator just for ease. Because I know that I'm going to use this. This is my secondary equation. So here's our secondary. So if this is our secondary equation, then where we're going to go from here. Our primary equation is the area which we're supposed to max. So we're supposed to maximize area, and our area is the area inside this rectangle, which is x times y, so xy, plus the area of half the circle. And the area of half the circle, right, the area of a circle, right, the area equation for a circle is pi r squared. So we only want half of that, so we get pi halves. R squared, if you think about this for a second, is the radius squared, which is x halves is the radius. So I'm going to simplify this a little bit. Remember, we're going to go back to this in just a second. So I'm just going to say that the area is equal to xy plus, remember when we do this, we have to be really careful that this goes to here and here. So we get pi x squared over 8, right? Because 2 squared is 4, 2 times 4 is this 8. That's where that came from, right? Now I'm looking at the equation, and the problem here is that we have a value of y in here. So what I'm going to do, I guess I am going to label this primary equation. So this is our primary. Here's our primary equation. Is I need to get this in terms of x. So what I'm going to do is I'm going to solve for y here in this equation. So I'm going to solve for y. And if you think about it, that's y in terms of x, and what you would get is y is equal to 32 minus 2x minus pi x all over 4, wouldn't you? And that's just the algebra I did there. Now I'm going to sub it into the primary equation. So sub secondary into the primary. So now what we have is area is equal to x times 32 minus 2x minus pi x over 4, wouldn't we? That's this part. That gives us this part right here. Plus we need this part, so plus pi 8 x squared, right? If you can see, I'm starting to try to set this up a little bit because I know I'm going to take the derivative of this. I'm going to simplify the area formula one more time, and I'm going to get area is equal to 32x minus 2x squared minus pi x squared all over 4 plus pi over 8x squared. I wanted differentiate this, so what I'm going to do now is this. I think I'm going to just start to ground this thing. Get 32x over 4 is 8x, isn't it? So area equals 8x minus 1/2 x squared, right? Minus pi 4ths x squared plus pi 8ths x squared. A couple things we can do here. I guess what I'll probably do here is this. I'll turn this into eighths. So I'll turn this into 2 pi 8ths. And if you can see why I'm doing that, it's because I'm going to combine these two like terms. I'm going to do this one more time. Believe it or not, we're getting there. 8x minus 1/2 x squared minus, right, because we have minus 2 pi 8ths here plus 1 pi 8th here, which is minus pi 8ths x squared. Wow, that was a lot, wasn't it? So from there, we're finally getting to where we want to be. Remember, we're trying to maximize the area and stay within our given perimeter. So I'm going to go ahead and take dA dx, a derivative of area with regard to x, which is 8 minus x minus pi 4ths x. Isn't that right? Right? And remember that because we want to max or min something, we want our derivative dA dx to equal 0. So we set that equal to 0. I'm not going to bother you with all the algebra that I did, but as I did my algebra, I set this equal to 0, and the final answer I got was x is equal to 32 over 4 plus pi. That's the x value. Right? And then we know that y, where's our value of y? We solved for y somewhere. Y was this. I substitute that value back into here so we could get our dimensions. All right, you guys, I hope this was really, really helpful to you. Your comments are always welcome. There is more arithmetic left to do here, but I wanted to make sure that I help you set up pictorially what this thing would look like and set up your secondary and primary equations, figure out how to take your derivative and where to go from there. So I hope this video was really helpful. If you haven't already subscribed, please do. Thanks.